Hello students, today we are going to do chapter 3, Laws of Motion. In this we have to do force, effects of force, kind of forces, out of which force and effect of force I have already done in one of the videos. So today I'll be emphasizing on kinds of forces. From the point of view of application, forces are classified as contact forces and non-contact forces. The contact forces are, if you have to ask to define the contact forces, we can give a simple definition as the forces which are applied on bodies by making a physical contact with them are called contact forces. These forces are produced and experienced when a body comes in contact with another body. The contact forces are of different types, like the frictional force, normal reaction force, tension force as applied through strings, force exerted by springs, and force exerted during collision of bodies. Now we'll discuss one by one the type of contact forces. Let's come on to the frictional force first. When a body slides or rolls over a rough surface, a force starts acting on the body in a direction opposite to the motion of the body so as to stop its motion. This force is called the frictional force or force of friction. Please remember that the value of force of friction is most of the time the same as the force exerted on the body, but it is up to a limit. There are different types of frictional forces: sliding force, static force, and rolling friction. In the diagram, you can see very clearly the push has been shown towards the right hand side direction, whereas the force of friction is being shown in the left hand side direction. That means if we push a book in the forward direction, the force of friction will be acting in the backward direction. Coming on to the second type of force, that is normal reaction force. When a body is placed on a surface, the body exerts a force downwards equal to its own weight on the surface. But we find that the body does not move or fall because the surface exerts an equal and opposite force on the body normal to the surface, which is called the normal reaction force. In the diagram, if you see, the force due to weight of the block is in the downward direction, whereas the reaction force on the block by the tabletop has been shown in the upward direction. Now coming on to the tension force. When a body is suspended by a string attached to a rigid support, the body, due to its weight, pulls the string vertically downwards, and the string in its stretched condition pulls the body upwards by a force which balances the weight of the body. This force developed in the string is called the tension or the force of tension. Both the forces are always going to be equal and opposite, meaning the force acting in the downward direction due to the weight of the body pulling the string will be equal to the force of tension developed in the string in the upward direction. Therefore, we can say T is equal to W. Next type of force which we are going to discuss is force exerted by a spring. Let's consider a spring with its one end kept fixed and its other end is either stretched or compressed. Then the spring exerts a force F opposite to the direction of displacement of its free end. The magnitude of this force is directly proportional to the magnitude of displacement, and this force is called the restoring force. If you see the diagrams, in the first diagram, if we are pulling the spring, we find the restoring force is in the opposite direction, which means on releasing the spring will try to come back to its original state or the position due to the restoring force. In the another diagram, if we are pushing the spring inwards, we find the restoring force is acting in the outward direction, which means again, if we release the push, the force which we are applying on the spring will try to come back, and due to the restoring force will try to regain its original position. Now coming on to the force exerted during collision. When two bodies collide, they push each other. As a result, equal and opposite forces act on each body. These forces are the force of action and the force of reaction, which means when two bodies are colliding, the first body will try to exert a force on the second body, and in the same manner the second body will apply the force on the first body. The force applied by the first body on the second body will be equal to the force applied by the second body on the first body. That means FAB will be equal to FBA. Now coming on to the non-contact forces. The forces experienced by the bodies even without being physically touched are called non-contact forces. They are also known as forces at a distance because they are acting at a distance. Therefore, we call them as forces at a distance also. The forces at a distance, they are of different types like gravitational force, electrostatic force and the magnetic force. One by one, we'll discuss about the non-contact forces. First coming on to the gravitational force. In the universe, each particle attracts the other due to its mass. This force of attraction between them is called gravitational force. We can have an example like if we drop a coin, we'll always find it will always come towards the ground due to the gravitational force. The earth, because of its mass, attracts all other masses around it. The force on a body due to the earth's attraction is called force due to gravity. It is also known as the weight of the body because the weight of the body is also the force with which a body is attracted towards the center of the earth. We call it as weight of the body. It causes motion in the body towards the earth. If the body is free to move, which means the force of gravity always acts in the downward direction. Now coming on to next type of non-contact forces, which is electrostatic force. The force between the charges is called electrostatic force. This force acts between the charged objects even if they are separated. A very common example we can say, like a charged glass rod can attract the bits of paper due to electrostatic force. Now coming on to magnetic force. The force between the magnetic poles is called magnetic force. This force acts even if the magnetic poles are at separation. We can give an example like when a magnet is brought near iron nails, the iron nails get attracted by the magnet due to the magnetic force. In case of a magnet, we can also say the like poles of magnets, they repel each other, whereas the unlike poles of magnets, they attract each other. We can discuss about some of the general characters of non-contact forces, which are very important to know. Like the gravitational force is always attractive in nature, whereas the electrostatic force and the magnetic force can be either attractive or repulsive. The second characteristic is the magnitude of non-contact forces on two bodies depends on the distance of separation between them. Its magnitude varies inversely as the square of the distance of separation. We can write it as F is proportional to 1 upon r square, where r is equal to distance of separation. Thank you.